Всем привет! Меня зовут Андрей Бородин, и мой
Hello
соведущий
everyone, my name is Andrei Borodin. My co-presenter is Evgeny Dyukov. We developed management database in Yandex Cloud, and today we would like to speak about some problems of using high availability DBMS in cloud.
В Яндексе у нас много Postgres.
In Yandex there are a lot of Postgres. Probably you know that we have Yandex Mail that gets about 1 million queries per second. It is in Yandex Cloud. I mean, the base of Yandex Mail are in Yandex Cloud, as many other services of Yandex. And totally, in Yandex Cloud, about 3 million queries per second are received. So, let's talk about the things that we want to get from Cloud database. First of all, we want it to be available all the time. We need 4 nines for reading and 3.5 nines for recording. So for reading, it means that total downtime should not be more than 4 something minutes. And we also want to get scalability in several availability zones in several data centers. And we would like to have relevant data copy in the analytical system. We need to have a reliable system that will satisfy the requirements of the service. And to build a reliable system, we can use our usual components. These disks are fault-tolerant. Processors and memory can break up, as well as connection. So, data center is the reason of fault in most cases. And normally this is the way we formulate our requirement of database. It should tolerate the fault of one data center, and it should not result in serious consequences for the services that use the database. Another interesting aspect, speaking about clouds, is virtualization. Virtualization is a way to mix up the load of different users. So some components use disk, others the central processor, still others the memory, and only when we mix up different load profile, we can get optimal use of the equipment. But speaking about virtualization, at some point one user may want more resources. They may need vertical scaling. And for the service, it looks like an inability to provide the resources. Well, it is not a fault, but this is a situation that requires serious change. And it can be referred to as a problem that can be resolved with high availability means. The standard approach to solving these problems is redundancy. So it means that we duplicate the equipment that allows us to be ready for faults. This approach is used in many cases. For example, airplanes have more than one engine normally, and other technical systems have redundancy as well. In cloud, a standard way of using duplication would be to use network disks. However, these disks resolve the issue of scalability for programs and systems that are not ready for scaling with their own means. And the database is written with the account of fault tolerance problems. That's why network disks will not be considered here. To use redundancy, we need to be able to create database copy and make it as relevant as possible. Traditionally, in Postgres, write-ahead lock is used for it. And the main question, speaking about developing a relevant copy, is the way of delivering write-ahead log into the place where it will continuously restore most relevant state of the database. There are two technologies to deliver the changes that occurred in the writer node to the node where only reading queries can be fulfilled. This is, well, I cannot say that some of them are simple and others are complicated. But one of such ways is write-ahead log archive, when on the write node, archive command is called. It saves a segment of a service of the archive, and on the restoring node there is a restore command that checks whether a new segment is present or not, and if it is, it brings it for restore. We need to understand that archive doesn't cancel replication, and replication doesn't cancel archive. A problem is that archive is a simultaneous interface, and it executes restoration and archivation on file-by-file basis. Many servers can implement this interface. Streamline replication. These are several processes. Wall center process is launched on the writer node. It reads write-ahead logs from pageable and by TCP send them to wall receiver following the standard processor protocol that pull this wall next to the replica, and the startup process of the replica, the corpus, execute these records and restore by each record the most relevant state of the copy. Streamlined replication also allows us to create cascades that is useful when the resource of network interface of the writer node is limited. Besides, streamlined replication accounts for the use of slot replications. They write the amount of data that were sent to the replica and the amount of data that were executed by the replica from the thread of write-ahead log. They are measured in bytes, and the coordinates are stem logical sequence number. Streamlined replication can be synchronous or quorum. It means that we have one guarantee. It's quite simple. When the client executes write-in transaction and call for commitment, database does not confirm query execution until write-ahead log is transferred to the necessary number of synchronous replicas or quorum of synchronous replicas. Another important concept in Postgres replication is timeline. Every time when we install the base from backup or convert reader node into a writer node, the coordinates of write-ahead log choose a new timeline in order not to mix up the measurement history, the measurements that were made on different nodes. And if replica did not stop in the timeline we need, we have an opportunity to travel in write-ahead log to the past. This yellow line is a timeline, and we can use pgrewind utility to go back, and after it reaches the point of new timeline, we can start a story of a different timeline that was archived on a different node.
So logical replication is a replication where we transfer non-binary changes, which bytes change on which page, but lists of modified lines in the database which were remotely created or modified. And logical replication has a number of benefits. It can help transfer changes to a portion of the database. Logical replication can also transmit data to another database of Postgres, and the receipt of logical data in logical replication is much easier than in physical replication from the software development point of view. And also it is possible to do major upgrade of the Postgres in the real-time mode. This is the topology of the cluster in the cloud, when we have some writing node which sends changes to the logical system. Synchronous and non-synchronous replication sends changes to the self-restoring nodes, and we can perform reading queries, and also those nodes ensure backup copying. And there are primary nodes, writing node. We can do archiving to the object storage. In our case, it is Yandex object storage. How do clients know where to go in this topology? We use target session address technology, where we indicate all hosts in each line of connection. Also, in the connection line, we mention the desired level of recording. The driver, be it GX, or APQ, or PGSQL, or JDBC, it will go through the list of hosts and ask each host, select TCG recovery, and if the node is not in the restoring mode, then it can accept writing queries. What happens when we reconfigure topology? The client receives a disconnection or hanging connection. With timeout, he understands that it is necessary to search for a new writing module in the cluster. It is critical to configure timeouts accurately. TPC uses a timeout time of expectation, and also correctly configure keep alive count. So keep alive will help understand that the network connection has been disrupted, and we need to look for the writing node again. So in this topology, sometimes we need to cover the writing node from the load, stop it, and promote to the synchronous replica. So convert the writing replica to the converting module, and return the writing node to the cluster by attaching it with the replica to the primary node. Do it with DBA is not easy. There are a number of systems that can orchestrate all this. PG out failover, but the most common one is Patroni, Stolon, and RepMGR, and many other great tools. Sergey Dyukov will explain how we wrote our HA solution, how we developed this solution together. Hello everyone. Let's start from the overview of a standard cluster. Fail-safe guarantee. We use an agent on node with Postgres. A lot of utilities use this, like a table, for example, as a DCS. We use Zookeeper, and Zookeeper cluster has several thousands of clusters of Postgres. It makes our life easier because there are fewer machines. To protect from the load, we stop the connection puller, so we may not need to stop Postgres to do the reload. So this has been in production for more than 6 years. Let's have a look how the failover takes place. Let's have a look at the simple case of primary of failure. This may be due to the network or hardware failures. So log is kept in the Zookeeper. When PGSync at the replica sees that log is not held by anyone, it starts coordinating the failover. As soon as we understand which node is going to be the new primary, PGSync takes the log and launches promote. When the new primary node is fully available, we can turn the remaining replica to it. Starting from Postgres 13, it happens without restart, at the older version with restart.
Мы не хотим жертвовать доступностью,
We
если
don't
можем.
want to sacrifice
Если у нас случился
availability,
отказ всех
if
реплик, но
possible.
primary
If all
доступен и
replica
DCS
fail,
жив,
but primary is
то мы
available and DCS
переключаемся в
is alive,
асинхронную
we
репликацию.
switch to asynchronous
Логично, что это приводит к
replication.
невозможности
This
фейловера,
leads
пока у
to
нас не появится
inability of
хотя бы одна
failover as
реплика
long
и
as
не
we don't have at
синхронизируется
least
с
one
primary.
replica and we don't synchronize with
Такие
primary.
оптимизации могут быть весьма
Such
опасны.
optimization may be quite
Дальше мы
dangerous.
посмотрим, как же мы проверяем,
We'll
что
see
мы не
later
теряем
how
данные при
we
их использовании.
verify that we don't lose data as we use them.
В распределенных системах очень много
In
движущихся частей.
distributed networks, there are a lot of moving parts, and a
Люди
lot may
обладают
go
достаточно
wrong.
ограниченной фантазией в
Humans
вопросе того, как систему
have limited
сломать.
imagination
По этой
on how
причине
to
часто
break the
полагаются на
system.
фазеры.
For that reason, they
Существуют и
rely on
похожие на них
fuzzing.
утилиты для тестирования
There are
распределенных
similar
систем.
utilities to test distributed
Мы в
systems.
качестве такой утилиты, или
We
скорее фреймворка, выбрали
use
Jepsen.
Jepsen
Вот
as
так в
such a
общем виде
framework.
выглядит наш тестовый стенд.
This is what our
Поднимаем
test stand
группу
looks
контейнеров с
like.
помощью Docker
We
Compose.
take a group of
Дальше
containers
Jepsen
with
входит в
group
SSH на
compose,
контейнер,
then
чтобы
Jepsen
запускать так
enters
называемые
the
немезисы,
container
поломки.
to
Он же
launch
запускает полезную
the
нагрузку в
failure.
Postgres с помощью JDBC.
It launches useful
У
load
Jepsen
with
очень много
means of
методов определения аномалий в
JSBC.
распределенных
There are a
системах.
lot of ways to
Но так как
identify
нас интересует
anomalies in
только потеря
distributed
данных,
systems, but
то мы
because we are
используем очень малую
interested in
часть
the loss
доступной
of data,
функциональности.
we use very
Поломки,
little
которые мы в классе наносим,
functionality.
тоже не очень
The
сложные.
breaks introduced in the cluster are not
Мы
very
используем три
complex.
базовых сценария
We
и
use three
комбинируем их в
major
различных
scenarios and
сочетаниях,
combine
оставляя
them
небольшие
in different
случайные
ways
задержки между ними.
by making
Первый–
random
это
delays
нарушение
between them.
сетевой
Number
связности
one
между нодами, прямо как в
is
реальной жизни, когда
distortion
пропадает
of
связь
network
между
connection
дата-центрами.
between nodes when
Второй–
there is
убийство
loss of
некоторых
connection between
процессов,
data
например, Postgres, Bouncer
centers.
или Small
Number
PGC
two
девяткой. Это позволяет
is
воспроизвести out of memory с
shown
плохо
on the
настроенным
screen. We can
OM-киллером.
do out of memory with
И
poor
третий–
OM
это запуск
killer. And
свитчовера,
third
так
scenario
как это
is
делают
switchover
пользователи
launch,
через
the
control point
way
нашего
users do
database
it through
сервиса.
control
Таким образом,
point of
мы
our
убеждаемся,
service.
что если пользователь
By
запустит такую
doing
процедуру
this,
и у
we
нас
make
случится
sure
что-то
that if the user
непредвиденное,
launches this
данные
procedure and
он
something
не
unexpected
потеряет.
happens, he will not lose data.
Тестовая нагрузка у нас
Test
достаточно
load
простая.
is quite simple.
Создаем таблицу из одного
We
поля
create
и
a
пытаемся в
table
нее
out of
вставить
one
значение
field and
глобального
try to
счетчика.
insert values of the
Делаем мы
global
это во всех
counter into it.
Postgres-ноды
We
вне
do that
зависимости
in
от
all
того, какая у них
Postgres
роль.
nodes, regardless of what
Логично, что
role
на
they
репликах
have.
запрос
It's
падает,
logical that
а на primary в большинстве
the
случаев
queries are
проходит,
lower in
за
replicas,
исключением случаев, когда PGCN
except for
потушил пулер
cases when
или
PGCN
недостаточно реплик, чтобы
killed the pooler
удовлетворить
and there are not
условия на
enough
синхронную
replicas to meet
репликацию.
conditions
Мы
for
запоминаем
synchronous
успешность запроса
replication.
и
We
используем
remember
это
the
для
successful
понимания,
query
потеряли ли мы
and use
данные.
it for understanding whether we lost data or not.
Мы можем разделить результаты
We
запросов
can
на несколько
split
множеств,
the query
некоторые из
results into
которых
several
пересекаются.
multiples.
Первое–
Some of them
ошибки,
overlap. Number
которые можно
one
разделить
is
на известные и
errors,
неизвестные.
can be
Известными ошибками
separated
мы
between
называем
known
ответы
and
от реплики
unknown.
невозможности вставить
Unknown
данные.
errors,
Все остальное–
it's an
проблемы с
answer of
сетью, падение
inability to insert
Postgres
data.
и так далее,
The rest
потенциально
is
может
issues
приводить
with
в
the
итоге к
network,
успешным вставкам.
down
Например, если мы вставили значение, оно
downing of the
реплицировалось, но мы не
Postgres.
смогли
But if
получить
we
его как
insert
primary,
value, it
соединение
was
прервалось.
replicated, but we couldn't receive it
А
as
вот если
primary.
primary отвечал
Connection
нам
is
ок на
lost.
вставку,
If
но мы в
primary said
итоговой таблице
OK for
значений не нашли,
insertion, but we
то это
couldn't find it
однозначно
in the
говорит о
final
потере
table,
данных.
this shows that data was
Давайте
lost,
посмотрим на реальный
were
пример багов,
lost. Let's
которые
have
мы
a look
таким
at the real
подходом поймали.
bugs by which we found by using this
Первый
approach.
пример достаточно простой.
Example number
Где-то
one is
7
quite
лет назад
simple.
мы использовали
7 years
звездочку в
ago,
качестве
we
значения
used an
для synchronous
asterisk
standby names.
for the value of
Это
synchronous
оставляет либо
standby
синхронные
names.
реплики за самим
This
Postgres. Чтобы понять,
Postgres
почему
then
это не всегда хорошо,
selects
надо
the
взглянуть на
replica. To
логику
understand why it is not
подосинка
always
тех имен.
good, we need to have a look at the PG sync of those times.
Вот интересующие нас части автоматов
This
PGSync
is
на
the
primary
old
реплике.
logic
На
on
primary мы
primary and
проверяем, держим
replica.
ли мы лог
For
в zookeeper.
primary, we
Если
test whether
терпим,
we have
то
lock in the
обновляем видимое
zookeeper. If we
состояние
do,
реплик в том
then
же
we
zookeeper.
update the
Это
visible
нужно для того,
replica in
чтобы
the
знать, кто
zookeeper.
синхронная
This is
реплика на данный
necessary to
момент времени.
understand who is the
Что
synchronous
мы делаем
replica
на
at a given
реплике?
point
Мы
of
смотрим,
time.
не
What do we
отпустился ли
do
лог
at the
primary.
replica?
Если
We see
отпустился,
whether
значит
the
primary
primary
упал.
log
Надо посмотреть, были
is
ли
there.
синхронные реплики
If
по последним
not,
данным. Если были,
then we
то
need to double
запромоутить.
check. If
Если интересным
it is
образом сломать
available, then
сетевую
we need to
связность, то можно
promote.
наступить на
If we
дырку.
break the
Посмотрим
network
на примере.
connection, let's have a look on how it
Слева у нас
happens.
primary,
On the
асинхронная
left-hand side, we
реплика
have
и один
primary and
хост zookeeper.
asynchronous replica and one
Справа
host of
синхронная
zookeeper. On the
реплика
right-hand
и
side,
два хоста
synchronous
zookeeper.
replica and two
Таким
hosts of
образом,
zookeeper.
кворум у zookeeper для
This is
primary
the quorum for
недоступен,
zookeeper
и
is
лог он
not
держать не
available.
может.
It
Синхронная
cannot
реплика со
maintain the
временем это
windows.
заметит
The
и
synchronous replica
запромоутится.
will notice it and promote. and will
Только если
promote.
Postgres не решит выбрать другую
Only
реплику
if
в качестве
Postgres doesn't
синхронной
decide to
и не
choose
успеет
another
ответить
replica as
клиентам об
synchronous
успешных
and fails
записях,
to
пока
answer
PG-Sync его не закроет
the
от нагрузки.
user on the
Так
successful
как информацию об
recording.
этом невозможно
Because
провести до zookeeper, мы
information
такие записи
cannot be
потеряем.
delivered to zookeeper, we will
Достаточно
lose
неприятный
these
сценарий.
records. This
Что
is an
можно сделать,
unpleasant
чтобы его
scenario.
избежать?
What can we do to avoid this scenario?
Давайте добавим еще один лог.
Let's add
Любая
one more
живая
log.
реплика будет
Any
пытаться его
living
взять.
replica will
А
try to take
промоутиться
it.
мы будем только если мы
And we will
держим
promote only
его
when
и
we
при этом были синхронной репликой с
hold
точки
it
зрения праймера.
and we were a synchronous replica from the point of view
На
of the
праймере мы
primer.
сравниваем текущего владельца
In
нового
primary,
лога
we
и
compare the
обновляем синхронно
current
standby
owner
names,
of the
если
new log
требуется.
and
А еще
update the
продолжаем
standby
обновлять
names if
информацию
necessary.
в
And we keep
zookeeper по
updating the
подключенных
information in
репликах.
the zookeepers
Слово
about their
«новое» тут в
connected
кавычках,
replicas.
потому
The
что
word
мы уже
new
очень давно
is
так
in
сделали, еще в продакшене даже
brackets
PG-Sync не использовали.
and in
Давайте
parentheses.
посмотрим на более свежий пример.
Let's have a
В
look
Postgres
at
есть
the
core
more
commit
recent example.
уже 4
There is a
мажорных
core
версии.
commit with 4
Можно ли
major
как-нибудь
versions.
хитро потерять данные при его
Is it
использовании?
possible to lose data in
Сначала
this
я немного
scenario?
напомню, что
Let
это и
me
зачем это нам
remind
нужно.
you what
Посмотрим
is
вот на
this
такой
and why
кластер.
do we
У него
need it.
5 нод.
Let's have a look at this
Одна
cluster with
primary,
5 nodes.
остальные
One
реплики.
primary, the
Когда
rest
мы
are
коммитим на
replicas.
primary,
When
LSM
we commit on
увеличивается.
primary, LSM
В данном
increases.
примере с 1 до 2.
In this case, from 1 to 2.
И в
It
случае
goes up from
необходимости
1 to
ожидания
2.
ответа реплик,
If it is
мы
necessary
можем
to
ждать не
wait for the
какую-то
answer from
конкретную, а
replicas,
любую,
we
если нам
may
достаточно
wait for
одной коммитки.
any, if
Это
one is
позволяет нам
enough,
не
of course.
завязываться на
This
производительность одной ноды.
helps us not rely on the
Очевидно,
productivity
что
of
так мы
one
не
node.
сможем избежать потери
Obviously,
данных.
we will
Нужно
not be
ждать
able
как
to
минимум 2
avoid
реплики из
loss of
4,
data. We need to
чтобы
wait for 2
большая часть
replicas
хостов
out of
имела
4
LSN равный
to
2
make sure
перед отдачей
hosts
подтверждения клиенту.
have 2 before they give over to the client.
Увы, увеличение производительности
Alas, higher
приносит значительные
performance
усложнения в процедуру
will
переключения primary в случае аварии.
complicate switching to primary
Рассмотрим
in case
достаточно
of a
простой
disruption.
случай с
Let's
нарушением
have a look
сетевой
at a
связности.
simple case with distortion of
В
network
нашем примере
connectivity.
primary
In
увеличивает
our
свой
case,
LSN до
primary
2 и ждет 2
increases its
реплик перед
LSN to
отправкой
2 and
подтверждения
waits for 2
клиенту об
replicas
успешной
before it
записи.
sends confirmation to the user on the successful
Зачем нужны
record.
2 реплики?
Why
Это
do we
позволит нам
wait for
принимать
2
решение о
replicas?
выборе
It will
нового
help us to
primary,
make a
если нам
decision
доступна
on
большая
selection
часть
of the new
хостов, не
replica
теряя при
if
этом
most of the
подтвержденные
hosts are
клиентом записи.
available, and we also keep the records confirmed
Когда
by the
случается
user.
поломка,
If
мы
disruption
проверяем,
occurs,
доступно ли
we
нам большинство нод,
check
и
if
выбираем
most of
ноду
the
с
nodes are
максимальным
available
LSN.
and select the
Таким
node with
образом,
the
пока
maximum
живы хотя
LSN.
бы 3 хоста из 5, мы
As long
поломки
as 3
переживаем.
hosts out of 5 are living, we can
В нашем
survive the
примере для
disruption.
недопущения потери
In our
данных
case,
необходимо
to
выполнить
avoid loss
реплику
of
с
data,
LSN
it is
2.
necessary to
Осталось
have
только
replica
понять,
with
что же это
LSN
за
2.
LSN
We
и
need to
как его
understand
правильно
what this
узнавать.
LSN is and how to recognize it in the right way.
Упрощенно мы можем представить изменения
To
LSN
simplify
вот
this,
таким
we can show
незамысловатым образом.
changes of LSN
Primary
in this
увеличивает
way
свою
on the
позицию,
slide.
посылает
Primary
val на
highs
реплику,
its
это
position,
set LSN.
sends val to
Реплика пишет
replica,
val на диск, это
replica
write
writes
LSN.
val on disk,
Синкает записано, это flash LSN.
synchronizes
И в
the
конце
record,
концов реплика
and
проигрывает изменения val,
replica
продвигая replay LSN.
plays val
Клиент
changes.
может ждать
The
подтверждения 3
client may
последних позиций.
confirm the
Записи,
last
синка на
3
диск или
items,
проигрывание изменений. Или
recording
не
or
ждать
playing
реплик
of
вообще.
changes,
Но в
or not
последнем
to wait
случае
for replicas
гарантировать
at all.
сохранность
In the
данных не
last
получится,
case,
так
we
что мы
cannot
ожидаем, что
guarantee
клиенты ждут хотя бы записи val на диске.
data availability.
Так
At
вот, для
least the
последнего
user
случая
should confirm
есть
record on the
замечательная
disk.
функция
So in the
PG
last case,
last
there
val
is a
receive LSN,
great
которая позволяет нам
function
получить что-то между
which
write и
helps
send.
us obtain something
Давайте
like
ей
this.
попробуем
Let's
воспользоваться
try
и
to use
посмотрим,
this
что будет.
and see what happens.
А будет потеря данных. Тут
We'll
надо
have loss of
напомнить, что у нас
data.
не просто сеть
Let me
ломается, а еще
remind you
процессы
that this is
убиваются.
not the network
Если это
disruption,
сделать
but the
одновременно, то
CPU
при старте
disruption.
Postgres
If we
val
do this
receiver начнет с
simultaneously,
начала
val
сегмента,
receiver will
из-за
start
чего
from the start of
используемая
the
нами
segment,
функция будет возвращать LSN
and
в
the
прошлом,
used
при
function
этом
will
достаточно
return
длительное
LSN
время.
to the past for a long time.
Тут можно смотреть на PG
Here we
last val
can
replay LSN, но не получится всех наших клиентов
look
заставить
at
ждать реплей для
the other
подтверждения.
command, but all clients will wait for replay
А смотреть
to be confirmed.
за неизменностью PG val receive LSN также сложно,
PG val
потому
receive
что
LSN
это
traction
требует
is
подгона
as difficult
тайм-аутов для того,
because
чтобы
then we'll need to use
угадать
timeouts to guess
ситуацию, когда мы не теряем данные. Так что нам нужна
the situation
какая-то
where we're not
альтернатива.
losing data. So that means we need an alternative
И эта
of
альтернатива
some
весьма
kind.
проста.
And this
Читаем в
alternative is
рамках
quite
этого.
simple.
Делаем мы это с помощью экстеншена, который смотрит
We
на
use
replay LSN и
extension,
бежит
looking
XOR
at
crypt
repo
рекордом,
SN,
пока не не споткнется.
So
Примерно
basically, it
так же
runs
делает
until
тот
it
же Валдам.
stumbles, This is what pg-val dump does. You can do it, but val should be read more. And now Andrei will explain why all this is still not necessary to keep data intact, not to lose data. Yes, imagine we have a cluster where all issues mentioned by Sergey have been addressed. Then we have other new issues emerging. One of them emerges on the side of the query. Cancellation of query is important. If the server is overloaded, the driver of the client will automatically cancel the long-standing query, and the client should repeat it after some time to give the system to digest the peak of load and try to handle the pressure of queries. What guarantees are provided by synchronous replication in the cluster? For example, we have 3-tier cluster with synchronous replication. We have network partitioning, when primary instance is cut from the network from the rest. Any query must hang on the synchronous replication. This is a guarantee that we provide. What is the pseudocode of transaction? First, we find data that we want to modify, block from change, block them from modification, then change them in shared buffer. And before we record anything in English, we need to write a head log that we flash locally and remotely to some of the replica. We wait for both these things happen, or both events happen, or we wait until flash of LSM will get to a necessary point in the transaction. Then we can log data, and these data will be observed by new transactions. You also need to understand that replica may show inconsistent data. A good example is when replicas are lagging behind from the primary node. But it may be the opposite. If primary instance has a very slow disk and replica has a fast disk, then it gets val faster and applies it. And in principle, on the replica you can see data which are a bit ahead of the primary instance, because primary instance does not immediately raise logs from data, and on replicas those constraints will be lifted right after delivery. But the situation may aggravate. Let's have a look at the cluster of 5 nodules with arguable application on 3 nodes. 3 remaining nodes in one available domain of the node can select a new primary if they believe that all the rest are cut from the network. Imagine this happens. Primary node and 1 quorum replica are cut from the rest of the cluster. With that, the data that we try to commit to in primary those data are blocked on primary. We cannot see them, but we can see that on quorum replica, which disrupts causal consistency, and the external systems may believe that those data have been saved. But this is not the main issue. Let's move to the more serious issue. Let's imagine we perform a query that contains insert and conflict do nothing. From some queue before the cluster, we need to insert it into the database. If the data has been inserted, it's an important question. We may repeat this query. We may think we may repeat this query, but in real life, it turns out that if this data are already in the database, we don't need to record anything. So we won't have to wait for flash on the disk and we won't need to wait for the synchronous replica. If we send such data in primary, cut from the rest of the cluster, we wait for synchronous application because the cluster is cut off and no synchronous replica will not be able to confirm data. Then the driver says cancel.
We wait for some time, and after that the driver is cancelled. Postgres will remove this query. The data will be committed locally. And if the client tries to execute this query once again, they will get confirmation of the transaction because these local data are visible, although they were not replicated on a replica. So, after we realized this problem, we developed a patch that prohibits cancellation of executed locally query. This patch is available on Commit Fest, but unfortunately it can resolve the problem with query cancellation only. So, if we reload the cluster, this problem can be resolved as well, because the locks installed on the data will disappear after the cluster is reloaded. So the system that provides for high availability of the cluster should monitor cluster reloading, and if the cluster is not a primary instance, after reloading, it should prohibit reading queries to get into the cluster, into that node, until it is a full-fledged participant of a full-fledged replica in a newly built cluster. More information on this problem can be found in PGCon Unconference 2020. Let's speak about changed data capture. So, we take the changes, we capture them, and bring them to the analytical system. This is the scheme of our system. And from primary instance, we logically stream our data into the system. We should be ready that master in this system will change. And logical replication can be sent from master alone. This is a problem, because we need to change the threads of logical replication. Similar problem was seen when building analytics calculated by Postgres means. We needed to have replicas that will never become masters. This is non-highly available host groups. So, we have a group of hosts that are HA hosts, highly available hosts, and they are authorized to transfer writing node, and everyone is streaming the changes from the current master. That is important to provide for data security. And we have hosts that are not hosts. They stream from one and the same replica. If one of the replicas fail, then the whole branch of this tree of cascade replicas fails. This is a problem. And we do not have clear rules regarding appropriate rebuilding topology of non-HA replicas. This idea of non-HA replicas does not help CDC because CDC in Yandex this is data transfer management. It is available in cloud only, and it can implement changes from Postgres, but we can stream these changes from primary instance only. To start streaming changes, we need to develop a slot. Physical replication slot can be created in the past. Logical replication slot can be created only in the current LSN. So, if after failover some time passed, Between the launch of a new master and the connection of change monitoring system, we have a hole in the logical replication. It's not good for us. It's not possible to create a logical slot in the past. What can we do about it? Well, we could develop a logical archive. In physical replication, this replica comes to the current master, stating, I need this wall, master states, I do not have it. Then the replica will go to archive and find it in the archive because it is available together with point-in-time recovery. We do not have a logical archive. So, what could we do? Probably we could teach wall G to decode wall in logical stream. So it seems that for Postgres to deconstruct wall into logical stream, it's necessary to have shared buffers So it's necessary to have this PB data that can take several terabytes. We haven't started work in this area, but this idea of having a physical wall in logical replication is very attractive for us, and we would like to see it. In analytical systems, sometimes we face a strange situation. Analytical systems can be ahead of synchronous replica. A synchronous replica is not always the newest replica with newest data. It can be just a replica that was designated as a synchronous one, and analytical system can be ahead of quarrel. And if failover occurs, if master changes, the analytical system will get some data that were not present in the timeline that remained the main timeline for the cluster. It would be convenient to have a logical rewind, but unfortunately it does not exist. It's not possible to rewind the flow of change in the other direction. To resolve these problems, we had to go to Postgres kernel. So we developed pjtm aux extension, auxiliary function for data management. This execution allows us to create a function to create it in the past. Probably in Postgres 15 we will have a function for creating replication slots in the past. We need to understand that if there are no WAL files about the past, it's not possible to create a slot. If there is a vacuum in the catalog, it's not possible to develop a slot in the past. It means that this extension does not give us any guarantees, but at least it is an attempt to do so. I would like to say a few words about similar technologies in MySQL. This is a serious database where logical replication was developed in a much better way, and all fault-tolerant systems were implemented on the basis of logical replication. There are several features there. The first feature that is noticed by everyone who is involved in change archive. If we do not have archive comment, it will not be synchronous. It means that we need to have a cron that will be scanning whether there are new logs that should be sent to archive. It's not convenient at all, but still we can do with it. In MySQL there are no timelines. Every host writes bin logs with their numbers. For example, in one cluster there can be bin logs written by different nodes, and their numbers will be different. So, when we restore a cluster where primary instance was changed, we want to save 3 stories. And if we want it to be efficient, then these parts of story that did not happen should be deleted from the storage, or at least they should not be archived. and this is a complicated technical task. I'd like to say a few words about the advantages of MySQL. Logical transaction coordinates, z2d sets. They describe the position of every node of a cluster in all the history of changes at the same time. This is a genius technology, and I would like to have it in Postgres as well. And the main thing is that MySQL logical replication can position, so it can understand how much one replica lags behind the other. Not with the use of LSN or physical lock, but with the use of z2d. This is very convenient. The instruments that you can use here.
Well,
the simplest one is the patch
запретом возможности отмены синхронной репликации. Два отрицания, но без этого никак, к сожалению.
for disable cancellation of executed locally query. Evil dump extension. This extension allows us to install true LSN,
была накачана репликация на реплике.
for which replication was used on that replica, and BGDMO's extension that allows us to develop logical replication slot in the past. All of that is available in GitHub or in CommitFest, and we will appreciate any feedback. And in conclusion, I'd like to mention that high availability is complicated. Indeed, there are a lot of problems there, but we do not face them frequently, and the main thing is that we can do something with each such problem. We are very responsible for every byte. And we think that we have managed to develop a system that guarantees data protection with the set parameters. That's it. We will happily answer your questions.
I'm
happy to welcome the speakers on air, and we are ready to start our Q&A session. Hi everyone. Hello. So we are waiting for questions on the chat, and I would like to thank you personally for the presentation. I watched it for the first time, and it's really great that you have this high-level description of the system, and you also described very interesting details. And now we have a question on the chat. In Avita, they developed select for update for the queries where it's important to read only the information replicated on the replica, and this selects will be slow if there is no synchronous replica. Oh, this is not a question, I guess this is an answer. This selects will freeze if there is no such replica, so it is possible to detect this situation. That's true. Select for update approach works, but select for update changes data.
Xmax для таплов, которые лочит.
It creates Xmax for the tuples that locks. If several transactions lock the same tuple at the same time, multi-exact multi-transaction is developed, it is physically recorded. So we came there to read, but the data start changing, and it's possible to have some problems with the performance. Multi-transaction system is single-thread system, so it will be difficult to resolve it. In CommitFest there is a patch that can improve it a bit, but this problem of multi-transaction is that this problem lags behind. It's difficult to reproduce it in a laboratory. So in principle, this approach can resolve a number of issues, but I would recommend you to use a patch for disabling cancellation of transaction, awaiting for synchronous replication. And actually, I wanted to congratulate Anastasia with the status of major contributor, because you actually introduced yourself as a contributor, but I thought that probably you don't know that you are already a major contributor. Oh, thank you. Yes, I'm just being humble. So we do not have many questions on the chat, so I would like to ask my questions. I'm wondering, how do you return replicas if one replica fell and master wants to go back after a new master was selected? You do PT rebind or you started from scratch? Well, it's interesting. At first, we wait the connection because probably there is partial connectivity and we can see zookeeper hosts but not primary ones. And if we try to launch rebind against the host that is not available by the net, rebind will fall. And after that we try to do rebind. If we did not manage to do so, or if after we did rebind Postgres did not manage to get the primary, then we will refill it from backup. And there is an interesting point here. When we do promote, when we select a new primary, then some part of the wall that we had in the old primary can be in archive. So, val is recorded locally on primary, and after that it is sent to replicas, and archiver can have some time to download files. The history file should be in archive. It's important to avoid the problem of timeline following. We manage it, and with follower from backup, our replicas are normally filled without problems. So the first attempt is rewind, and if we didn't manage to do so, we use backup. Thanks. Zhenya, there was a problem regarding the extra history file in the archive. Could you please remind me why it occurred? It occurred because sometimes we promoted unsuccessfully. And in that case, there is a probability that after the promote, Postgres will fall. And history file can stay in archive, and it's possible that we are on timeline 1, and we have two possible candidates, replica 1 and replica 2. We read to promote replica 1, it uploads its history file in the archive, but promotion is not successful. For example, there is a sig fault. And after that, we will not be able to promote replica 2 normally, because its timeline is 1. In the archive, we will have a conflict. We can download these files incorrectly. So from the archive, this file should be deleted, and after that we do promotion. So the key knowledge is that fail can happen when we work out this fail. Well, it is expected, but we want to avoid it. Thank you. Another question from Maxim Milutin. In your HA scheme, how do you fulfill fencing of an isolated master? I spoke about it. The matter is that we put puller below, so we have connection puller, and when we understand that we need to close the master, we just put it down, and clients cannot connect it, and replicas turn to primary. But we do not launch connections in circumvention of cooler. Right, client cannot connect without cooler.
Another question, how do you fight with logical replication base being so slow? Given the amount of modifications, everything will be quite slow in the loading system.
Я так понимаю, вопрос логической репликации
I
не
think
тормозит?
it's about logical replication and does it slow the process or not. We don't really see and feel this on our side. Logical replication. We use movement, we make movements with logical replication. Anyone who wants to move, they do that with logical replication, or they may face issues. I haven't had any questions or people coming to me with questions about performance. So it looks like this issue is not an existent issue.
Так, и еще тут есть благодарность за расширение
One more.
PGTM AUX.
Well,
Есть
people say
вопрос,
thank you for the
решает ли
extension,
PGTM AUX
and a
проблему с
question:
восстановлением логической репликации
is it possible to
после
restore
фейловера
logical
мастерную
replication
потоковую
after
реплику?
the fallover of replic to the stream replication? Yes, this is done for to be able to create a logical slot on replica right after the fallover. And this is the purpose
Спасибо.
of this
И еще
tool.
вопрос, не пробовали ли вы
Another question:
синхронную
have you
логическую
tried
репликацию, чтобы
synchronous and
реплика не
logical
убегала в
replication
будущее
for the replica
относительно
not to run
стендбай,
into
на
the
который
future
фейловер идет?
related to sync standby?
Синхронность репликации состоит в том, что мы
The simultaneous feature of the replication is that we delay confirmation to the client. At the same time, we do not stop the attack on replica and emergence of data. Replication may be faster than synchronous replication, and the simultaneous feature of the replication doesn't prevent this. But this is an open issue. The analytical system may be a bit ahead of the cluster, and in case of a failover, it may have data which have not been delivered. But I guess this
уже
is a
есть какая-то
question
работа
for
в
Postgres
прогрессе на этом
15.
части?
Do you have work in progress?
один раз поговорили про это
We discussed it once.
Ну, не знаю.
Вот сейчас второй раз поговорили. Можно
This
сказать,
is the second time we discuss it. That means it is in progress, because interaction and dialogue is part of the process, so we are moving forward, of course.
Привлекли внимание к проблеме, значит, начали ее решать.
So we rose the issue, that means we started addressing it. Yes, it's good that you have identified it. One more question. Prohibition to bring the transaction back, may it lead to permanent, when the client permanently waits for the transaction? Yes, this permanent waiting may occur, but in this case, the client should have statement timeout configured, and then he will understand that there is no point in waiting more. So cancellation of synchronous application should look like this. If the client is connected to the old primary node, he should be prepared that it may not have a network connectivity with a synchronous replica, and all transactions will freeze.
Спасибо. И, наверное,
Thank you.
последний вопрос.
And the final question,
Наши спикеры уйдут в special chat.
before our speakers move to the
Поделитесь
special
опытом,
chat,
не сталкивались
please share your
ли с проблемами
experience.
при
Have you
инициализации
encountered an
логической
issue
репликации
when
на
you
больших
initiate
таблицах?
logical replication
записей?
on big
Если
tables,
да, то
like
как
billions of
решали?
records? If yes, how did you resolve it? I do face it. I have people who came from Yandex, one of the Yandex services. They brought me the logs and said, so this is the report I received, and we see a mistake, an error that should have never had happened. So I saw this error on Friday, and I don't have a solution yet. There are some exclusive cases, and you need just to delve into it to understand the root cause. Table replication was possible even with more than billion records. 10 to the power of 9, yes, it was possible. 10 to the power of 12, probably not.
С проблемами сталкивались, проблемы чиним.
Yes, we've had such issues and we're addressing them.
Самое важное, что
We're fixing them. It's important that you fix them.
Спасибо еще раз большое за доклад. Спасибо
Thank you
за
for your
ответы на
presentations.
вопросы.
Thank you for the
И
answers.
теперь я предлагаю всем заинтересованным продолжить общение в
So,
special
anyone who is
чате с
interested
докладчиками.
can move to the
Напоминаю,
special
что за
chat and
доклад
interact
можно
with the
ставить
presenters.
звездочки, голосовать
And
и
please
всячески
vote for
выражать
this
спикерам свое
presentation.
одобрение.
Please
А
express
сейчас
your
у нас
appreciation.
5-минутный перерыв.
Put
И ровно
likes.
через
We're
5
going to
минут,
have 5 minutes
14:30,
as a
мы
break.
ждем всех в
And
эфире
at
для
2:30,
следующего
please
доклада.
come back for the next
Спасибо.
presentation. Thank you.